Today, we're diving straight into literally the mechanical heart of a diesel engine, the injection pump. We're going to discover exactly how this vital component manages the entire fuel metering process and pressurization, taking a static block of metal and transforming it into a powerhouse of torque and combustion efficiency.
Here's our roadmap for today. We'll be covering the beating heart, the journey of fuel, evolution of the pump, heart failure, and finally, preventative care. Let's jump right in. To really set the stakes here, let's talk about operating pressure specifications. Think about a standard car tire. That usually sits at, about 40 psi. Well, a modern diesel injection pump blasts fuel into an engine at a staggering 44,000 psi. That's over 2,500 bar. It's honestly kind of hard to even wrap your head around that level of pressure, but as you'll see, it is absolutely essential for the engine to function.
So, why do we need all that pressure? It's actually fascinating. Unlike gasoline engines, diesel engines don't use spark plugs. They rely entirely on the intense heat generated by compressing air in the cylinder. This means the engine is relying on the injection pump's perfect timing and extreme pressure to achieve proper fuel atomization and ignition. If this pump misses a beat, combustion simply doesn't happen.
Moving into Section 1, the beating heart, understanding extreme precision. Let's look at what this vital organ actually does for the engine.
This pump isn't just sloshing liquid from point A to point B. It's more like a master conductor. It pressurizes the fuel, meters the exact quantity based on engine load, times the delivery perfectly, and distributes it equally across all cylinders. Without this precise orchestration, you get poor atomization, which leads to a total loss of combustion efficiency, zero power, and a massive failure in emission control.
All right, Section 2, the journey of fuel, following the lifeblood. Let's trace a single drop of diesel on its high-stakes journey through the injection system.
The fuel flow process is brilliantly choreographed. First, a lift pump draws low-pressure fuel right from the tank. It enters the injection pump where internal plungers compress it rapidly. As that pressure spikes, a delivery valve pops open, crucially preventing backflow, and sends the fuel straight to the injector, atomizing it into a fine mist. And this entire four-step cycle, it repeats in mere milliseconds, beating in perfect rhythm.
When you look at the major components and their functions, the precision is just mind-blowing. Inside the pump housing, you've got a camshaft with cam lobes driving plungers into their barrels to compress the fuel. You also have a governor mechanism, which is essentially the mechanical brain controlling engine speed, and delivery valves maintaining residual pressure. Get this, the plunger clearances in here are measured in mere microns just to prevent fuel leakage under that massive pressure.
But here's the thing, pressure is absolutely nothing without timing. Injection timing is typically measured in degrees of crankshaft rotation before top dead center. If fuel enters a fraction of a second too early, you get violent diesel knock. Too late, you're looking at white smoke, high exhaust temps, and zero power. Whether it's controlled by a mechanical timing advanced mechanism or modern electronic sensors, preventing injection timing problems is literally the difference between a smooth idle and catastrophic engine failure.
Section 3. Evolution of the pump, from mechanical to electronic. Over the decades, this mechanical heart has undergone a massive technological evolution.
We can basically split this evolution into two distinct eras, mechanical versus electronic. On the left, traditional mechanical pumps are legendary for their ruggedness. They are incredibly durable and can run completely without an ECU. But on the right, modern electronic common rail systems provide vastly superior efficiency. By using an ECU to manage solenoids, they allow for multiple injection events per cycle, which is what makes modern diesels significantly quieter and cleaner.
Depending on your application, you're relying on a very specific architecture. Inline injection pumps have a dedicated pumping element for every single cylinder, making them the durable choice for heavy-duty trucks and agricultural machinery. Rotary distributor pumps are compact, which was perfect for older passenger vehicles. Unit injectors offer cam-driven precision. And finally, the common rail high-pressure pump is the modern standard, continuously pressurizing a shared rail for on-demand electronic injection.
Just look at this chart. The leap in pressurization technology over the years is staggering. Older mechanical inline pumps topped out around 8,000 psi. Rotary pumps pushed it to 15,000. But modern common rail systems completely dwarf that older tech, skyrocketing up to 44,000 psi to achieve unprecedented fuel optimization and power.
On to Section 4, heart failure. What happens when things go wrong with this incredibly robust, high-pressure system?
So, what exactly kills an injection pump? It's a critical question. Because these components are built with such extreme precision, their service life and reliability should span hundreds of thousands of miles. When they die prematurely, it's rarely natural causes. It's almost always outside villains. And here is your lineup of suspects causing injection pump damage. Dirt and debris and contaminated fuel will physically score those micron-tight clearances. Air in the fuel system causes cavitation damage. But water? The effects of water in diesel fuel are especially devastating. It strips away internal lubrication, violently corrodes those precise metal components, and can even promote bacterial growth right inside the pump housing.
If your engine's heart is failing, trust me, it will let you know. Common symptoms of injection pump failure include extended cranking, a surging idle, and a total loss of power under load. You might also see thick white or black exhaust smoke. And if you ever find fine metal particles in your fuel filter, yeah, that is a definitive sign of internal destruction.
Section 5. Preventative care, keeping the heart beating. Let's talk about diagnostic procedures and how to prevent these failures entirely.
Before anyone starts tearing the engine apart, professional testing equipment is key to looking inside the pump's performance. Technicians will hook up mechanical gauges for fuel pressure, use advanced scan tools to read real-time ECU data, check timing with dial indicators, and perform return flow tests to pinpoint internal fuel leakage points. But ideally, you never even reach the diagnostic stage, right? Sticking to maintenance best practices is your ultimate defense. Replace your fuel filters strictly on schedule. Drain those water separators regularly. Use high-quality fuel and never run the tank near empty. Doing that stirs up sediments and introduces air into the fuel system, which acts literally like a stroke to the engine's heart. Okay, before we wrap up, we absolutely have to address safety precautions when servicing these systems. Never, ever loosen high-pressure fuel lines while the engine is running. Remember that 44,000 psi we talked about? At that pressure, fuel acts like a laser beam. It can easily penetrate human skin and cause severe, life-threatening injuries. Always ensure the system is completely depressurized before touching it. Ultimately, the big takeaway here is that most pump failures trace back to fuel contamination or a lack of maintenance. Your injection pump's reliability and overall service life are almost entirely dictated by the quality of the fuel you feed it and the preventative care you perform. It really makes you realize just how crucial changing that fuel filter is, doesn't it? So will your engine's heart beat strong for another 100,000 miles, or is a microscopic drop of water already plotting its downfall? Understanding this immense pressure and microscopic precision leaves us with a profound respect for modern diesel injection technologies.